Welcome everybody to Google Developer Group's Dallas chapter April 2021 meetup. Tonight we are hearing from our very own David Parry with his talk, Getting Groovy with Spock. Let me tell you a little bit about David first. He mentors, designs, and develops for the Fullstack, MicroStack specifically. During his career, he coined the phrase, "Code does not lie." This is why you will observe him with his sleeves rolled up, implementing and testing his designs with fellow professional developers. He has worked for a range of companies, from startups to Big Four consulting firms, allowing him to have a wide range of experiences and opportunities. He's your friend and maybe even mine, our very own David Parry. Take it away, David.
Thank you, Luke. Yes, and just on a quick note, code doesn't lie. Just today, I actually went through and was looking at the code and needed to get a question answered, and just going back through and running through the code and watching the source code and reading it and figuring out how a certain functionality happened in search. So that's what I always say. You can watch a diagram or read something, but really, if you go to the code, that's real the truth is. So I'm going to go ahead and share my desktop. I'm hoping I got desktop 1. I think that's the right one. Okay, great. Is it allowing me to share? And later, okay. It wanted me to quit. Can everyone see my desktop now? Nope. It's saying I don't share all the time on Zoom. Now maybe. Okay, yes. Great. So it says now I'm sharing this screen. So this is Getting Groovy with Spock, and not just Spock, but the Spock framework. I try to make it a catchy little title. How many people should I raise your hands or know the Spock framework? Okay. How many people know Groovy in Java? Okay, so that helps me out too. And the key to this is, in going through this, is it's very Java-like. Groovy runs, it's part of the specs with Java, and it's a scripting kind of language, but it's taken on its own life now. And Gradle. Everyone knows and loves or hates Gradle. Well, that uses Groovy. So everyone uses Gradle here, yeah? And it's done anything to the Gradle file, maybe? Or maybe you're Maven still. I don't know. No? I see, like, Luke, you don't develop, Luke, but Ron, have you used Gradle? You're muted. So, and I don't mind having
No. I'm an open source web developer, mainly JavaScript, React. So
okay. So this is kind of not similar to the React and all that, but you'll get to it. And so with the Groovy, I'm just going to go into it. This is what we'll be covering today. So the thing called the specification. So that's kind of like the test class. Our fixture methods, also feature method. Part of the specification and what you're testing. So that is the specification. That's the main thing. Your setup, your stimulus, and your response, and then the cleanup. And then do you spin around back again? So this is unit testing. And maybe should I ask, everyone, I just assume this because we're 2021, but unit testing, knowing about testing your code, doing unit testing, no matter what language it is. There's the thing called the Groovy Truth. So what's true is true in doing your testing for things to be real, or 1 = 1, and it just equals it when you're doing the language of it back. And then the interactions with the mocks and the behaviors of the objects. So we'll go and look at that. It's not just, hey, do I have a state? Did I put values in this data and do I have it? But the interaction of it, oh, I was expecting this to be called and this to happen 2 or 3 times. Not only that, oh, this value was incremented to 3, but actually this method was executed 3 times to change that state 3 times, or did the state get changed some other way, but the method was only invoked twice? Those kind of things, and the call outs and stuff. Or, hey, you should have been calling to this web service 2 times and get the value, and you mocked out the web service, but your application only hit it once, but it returned you the right results because your state's right. So there's a lot of that. So like I said before, it uses the Groovy language, and I put this convenient little link here. And let me see, there's something. Okay, yeah, that's from Luke. Okay, so let me go back one. Sorry, I was bringing out here. I have this little this thing that won't get out of my way on the top of my screen. See, this is what I get. I don't use Zoom every day. And this is the Apache. So the Apache open source community is in charge of Groovy. And this is where I go to the syntax and direct everyone here as you're seeing this, is to be familiar with the language. And I'm, right now when we go through the test, that's why I'm keeping it very simple. Groovy can be integrated into Android because it's Java. You can even actually, test out Java. You can test out the other Kotlin too, because Kotlin and Java running together, they're 2 birds of a feather kind of concept. And and I'm trying to get rid of that. Okay, now it went down finally. Okay, so there we have that. This is the data-driven testing. So I'm going to show you in the Groovy and in this Spock language, or in there, it's a DSL for testing. It's very fluid and it's readable. So if you look at JUnit and JUnit 5, it started to become a lot more, you have data with it and can be readable, a little bit more readable. Groovy is just that much better because it's using the AST kind of tree and a language. It's a true language in itself. And it has sweet reporting on, things. You can have the data that you're testing and have the report error out, and you can see what data you're at too. It'll run with Gradle, it'll run with Maven. Java 8 plus or more and Groovy 3.0. It's based on Sputnik, which is the connection between Spock and JUnit together using the JUnit runner. So anywhere you can do JUnit, you can use Spock. Just have the actual jars and Groovy embedded in it, and you're off to the races. So now that's kind of an overview. There's not many slides. We're going to get deep into the code because I like to write code and go through the example. Before we go through the example, we say, what's the requirements? What's the ask? So I'm giving us a scenario so that we can have something that, get our teeth in and not just show classes and everything, but actually have a working model of this. So the ask was that we were asked to create a method that checks if the integer value is an even or odd number, and we return 0 for even and 1 for odd. And this is where this is interactive too, where I might mess up as we're doing this because I'm going to be live coding and going through this with you. And if I do, you guys need to, pair program with me, and maybe I return odd and even, I get the numbers mixed up. If the number is 0 or negative, it's going to throw a runtime exception. So that's the requirement. And there, if we look at our little image here, this is our diagram of what we want to achieve in our object model. And it's very basic that we have a couple of interfaces here. This is the Java world that you're probably used to, or if you're not, it's very simple. Understanding is the odd even camp, we have a check. So it's going to take in an integer like it's saying here, and it needs to return either a 0 or 1. We have a validator over here on the right. That's what's going to check for our negative check. So as you can see, the separation of concerns and work you want to do. So the odd even camp impl, that's what we're going to actually, that's our implementation. So we're going to actually implement it to take in an integer and to actually do the check and return back the positive or negative. The validator is already there for us, and we have a unit test on that. And so I'm just going to show how that can actually complement and be added into your code and your unit tested for that. I will pause if anyone has any questions right now for that. So that was kind of like an overview. I wanted to kind of give you an overview of where we're headed. And here is one thing that I'll put up. If I can do this correctly in the chat, this is my GitHub account for this project. You'll see I have a completed one too in this, and you don't have to look at it right now. This is for later. I usually share it afterwards, but I'm sharing it right now just so that people, you know, if you wanted to go along and it doesn't take away from you. And I have my whole getting groovy with Spock, and I have a little bit of stuff on here for my for the actual README and kind of give you some examples of stuff. And I'm going to try to use that, and you guys can hold me to it, to kind of go over, hey, what's the specification? Well, did we check that or not? So I'm going to go ahead, move this window off. We'll come back to the presentation down, and we're here on the IDE now. So as everyone can see my IDE, it's just IntelliJ. Great. I'm going to do my first thing that I'm going to do is I'm going to run the tests. So I'm going to see where we're at right now. So I'm just going to run the tests. As you can see that Spock is in that Sputnik runner, so it looks like to the IDE that it's JUnit. There is a little bit of added benefit here. And what I'm going to show you here is where I told you that this is a very basic DSL. And you'll see if I put something here though, and run it again, and you'll see more in once it fails, but you'll see some better outputs down the road too that I'll show you with the data. But it'll actually, you know, it sends up the message just like JUnit, get message from constructor, and it gives you some really nice output here that you really can see the differences and the similarities. Some very nice, which I kind of tend to like, and so much that I'm not comparing this to JUnit anymore. If you want to use JUnit, I just want you to do unit tests. You can intermix Spock with JUnit too, but to be honest, I have not been using JUnit for a while now because I'm so more fluid and more straightforward with Spock here. And then with Dart, everyone knows, like with Dart or other languages, there's another unit testing. So I don't use Spock for the front end in Dart. So it comes in. But so we're back to the testing classes. So if we go back to the requirements, and what I'm going to do here is show me the README and make sure we stay up on this. We're going to talk about specifications. We go to the requirements. We need this validator. We need to see 0 or 1 or odd or even. We already know now the negative check. We have a simple validate call with a validate interface. It says, oh, I'm going to take an integer and I'm going to see if it's null or if it's less than or equal to 0, and it'll throw an exception for us. So we already have that, and that kind of got our feet wet of here's just a basic test with Spock. You can do, hey, I expect with this new exception that I throw this, that the message will return me back test. That's all I expect. Whenever you throw that, give me the message whenever you create the that class. If I look at the negative, if I look at the exception itself, that's all it does. It's because it's calling super send that message. So I just want to test that this exception, that extends runtime exception, when you pass it a message, that it calls to the super object and gets it. So we're good to go there. We know that all works. Now, the next thing we want to do is actually write some code and get into there. So I have an interface for us. It kind of explains now again what we need to do. So we know the requirements. We came up with the interface. We all agreed that we wanted to use the call it check and have it return the integer. That'll make it right and take in a number. So that's the number we want to be able to check. And we're going to create a Spock specification is what it's called. So I'm just going to right click here because I'm a little lazy. You can create your own Groovy file on your own, the Groovy class, and extend, or you can use an IDE plugin. I'll use the Spock specification, and it's just going to add in the plugin. So I'm just going to, sorry, clicked off of that. What I wanted to show is you can do it either way. It's just kind of like a nice thing to do this. So I'm going to say odd, even, camp, impl, and I'm going to call it spec. And what this guy's going to do is, this is a naming convention. You don't have to use spec. You know, remember like JUnit, you had to use the test word back in the day and all that. It's just a convention to do that. So what it does though, when you do specification, all that did was create a just basic Groovy file for us and put the import and the package, because I right clicked on the package down here where I wanted it to be added, and the extend specification. Didn't do anything else for me. I could have just created a regular Groovy file and put specification, because that's all we have is a .groovy. That's what we're doing. We're getting groovy. So now the next thing I need to do is, we need to create a actual class that's going to do the odd even. And so I'm going to go ahead and say, okay, well, I want to create, and I want to check on time real quick, Luke. This is up until 8:30, correct? Or
yeah, and you can go longer if you need to.
Longer. Okay, cool. And if everyone's cool with that, I'm going to go ahead and say, okay, this is the odd even class. So I'm just going to create just a basic Java class right now that we need, and we want to implement the odd even camp interface. That's the one we agreed to. So I'm just going to call it odd even camp impl, and I got my unit test there. I'm going to hit OK, and I'm going to implement the odd even camp interface. So if I look at this, my little red guy here says, okay, I'm going to implement the method. All of these things you could just type yourself too, but being lazy, you use your IDE, or faster, or what do you want to say, more productive, whatever you want to call it. So right now, this is just returning 0. I have no test yet. So I now, at least I can test, doing like a test-driven development, testing some code, making sure that we got some code set up. I can come back into the Groovy specification and go and start doing some of these tests. Now, the one thing is, I know that we talked about the specification. So I'm going to go ahead and I'm just making sure that we hit our mark on the specification. So I got a little checkbox there, the Spock Lang specification. That was what we did here. We have our specification. That's a specification class. The next thing we want to touch on is the fixtures, the methods. So we have setup spec, cleanup spec. That's similar to setup and cleanup on the Java or JUnit world that it runs on top of. So we have these two that we want to add. So I can say setup spec. So I can come in here and do it's Groovy. So Groovy, you say, hey, I want to define this method, function, whatever flavor of the word you want to say. And by default, you can call setup or set up the specification. And each one of these, the setup spec is the one-time call. Setup is for each method that's getting tested. So if you have more than one definition test in this specification, setup will get called each time. So right now we're going to leave them blank right now, and then we'll see those run up down the road. And for the sake of time, I'm just going to go ahead and say, okay, I'm going to add the cleanup. So there's cleanup that can be done on every execution, and then cleanup can be done at the end of the specification. So think of if you're setting up something even a little bit more advanced than just what I would consider a unit test, but you need to set up and run up some mock database or something else like that. You want to keep it and know the state across the board, but at the end of the whole complete specification for all the methods, you want to shut that down. You can do that at that time versus every call. So maybe every call you want to remove a table or something, you can do that in your setup. Does that make sense to everyone? What I mean by the setups and setup spec? Cool. Alrighty. So now we're going to want to say, okay, well, I want to pass in a negative number, and I want to see, hey, is it going to be thrown or not? Is that negative number, what's going to happen to a negative number when we've passed in? Because remember, we have a negative number, we need to have a exception to be thrown. That was part of our requirement on the ask. Everyone remembers that. So we're going to say for negative number or 0, because remember it was 0, exception thrown. There we go, if I can type. Okay, so I'm going to say given, this is part of the language and making it clean, given for a negative, if I can type, negative checker, I'm going to say equals the new negative, negative checker. Now, this in Groovy, if you're a Java person or Groovy, you don't need semicolons here. So I can put them there, but you don't need them. And now I'm going to do my odd and even camp impl. And I'm going to say, okay, odd even camp equals new odd even camp impl negative checker. Now, some people will say, Dave, and I'll give you an example of this, that you're actually tying the two unit tests together. And I said, yes. For the sake of this, though, I'm just showing some different scenarios. Some might be good practices. Some might be fights over drinks or something at a bar, or you want to get into it. But I'm just using it as things. Your knowledge may vary on how bad you want to get on that. So I'm saying, given this, when this, I'm going to say odd even camp dot check, and I'm going to pass in a negative number. So I'm not, why is this giving me red now? Oh, so here's the other thing. I have IntelliJ, the new IntelliJ has built-in syntax checking for Spock framework. So someone at IntelliJ really liked it and they did it, or someone wrote to Spock. So if you see here, it says when requires a corresponding then. This is quite new. Today I just downloaded this new version and said, hey, do you want to do this? So you guys are getting to experience this with me. I don't usually have these highlighting like that. So I'm like, why is it red? But now it's red because it's telling me I need a then. So when then. So the inputs, outputs, so you read it, given something, when this, then this. I'm going to say something is thrown. What's thrown? Well, a negative number exception. So if you look, I'm expecting, we gave a -1. I'm expecting that when I call the check with a -1, we get a negative number. Now, this is test-driven development. So we know we have the method, but I don't have anything else. I'm just returning a 0. So right now we're going to run this, and we should celebrate that we got a failure. And Uncle Bob or other people probably are like, I'm not doing it 100%, but I'm trying to do them justice for test-driven development, all that. But I'm not it's a Dave Parry test-driven development, I guess. So we can see here that could not find, okay. Oh, sorry, I've missed one thing. You see here, I don't have an interface or the actual method here for this. So I'm going to actually now say, hey, I'm supposed to pass in the negative number. And I missed that one, but that's a good check on there. So I'm going to do a private, private, the validator. So for good development practices, we're going to say it's just the interface, the validator, because we're not sure who, what it more or less what they want. So I'm just going to say integer here and call it validator. And then I'm going to create a method. And I'm going to import the class. Has anyone got their hand up? Nope. Okay. So I'm importing the class. Then I'm just going to say, okay, public odd even camp impl. And I'm going to say, pass me in a validator. And here we go, making sure we got this. And oh, I want it typed. Oh, not that, sorry, my bad. We always get messed up there. This dot validator equals validate. There we go. Now we're going to run the test again. So quickly run this, and we're going to get another error in our test-driven development. So first we saw that we couldn't even set up the given. Now we got the given, but now what happened? So if we look, expected exception of negative number, but no exception was thrown. Oh, we're expecting an exception. So the key to this too, for me, I really like the output here. If you've written tests or you've done this, you have these ideas of brittle tests and people are like writing tests. The idea is not even in the beginning of the first one, it's 6 months down the road and test starts breaking and you're like, oh, I got to try to research this unit test and see all this stuff. This is really, to me, this has been a lifesaver to me because this really, a lot of this ceremonial stuff that you have to remember the right stuff. No, this is, I just say thrown. Part of the DSL, I say thrown, and it will come out with more information for me. It doesn't allow me to be terse. It makes it be more verbose, but my code is more streamlined and elegant, and the language speaks more. But when you do have a failure, it's a lot more verbose. So now we need to make this pass. So the test is not passing right now. So what can we do? Well, we know that we have the validator already. This is one of the things that I put in here for us is that, and then I did, that we have a validator in our first test to say, okay, for the sake of time, I wrote this and we went over that test and we said, okay, this is the negative checker and it's already going to do all this code for us. So that's a way for me to kind of cheat to be a little bit faster for you guys. And so you can see this. So I pass this in and this is going to throw that exception for me. So I'm going to go ahead and run this and we should see green if all else works. And the demo gods have gotten their validations correct from this week. And yes, they do. So this is awesome. Test to passed. We can also see that Groovy and Spock will create a output of a report of Spock tests. So we have odd even camp classes and all the Spock tests that can be printed out. And we'll look at that more. I just wanted to kind of touch base on that and let you see that there's a lot more reporting on there. But I'm going back to now my notes and the topics. We talked on the setup spec, the cleanup spec. We showed, I got those. We'll hit on those a little bit more. So I'm going to keep that one out of the checkbox. But we really did hit on a little bit of the heart of the specification and what we're testing. So I'm going to go ahead and say, you know, we can at least say that that guy kind of doing testing and hit the specification. Now what we're going to do is more of, okay, the setup, the stimulus, the responses, and the cleanup from that. So I'm going to go ahead and do another type of test that is more data driven for us. This is the funner one. And what's the funner one about this is actually seeing the data and how much nicer. I don't know if you guys have tested before, but it really gets hard. Like, well, do I have to bring in a file? Do I have a lot of data? How do I see it and read it and understand it? And this keeps it all in one place in this DSL. I also can do this. I'm going to say for the given value, and then I'm going to put in here, you know, the number, whatever the number is. Now, here's the key. See this pound sign right there? This is going to allow me to report based on the data that we're giving in and where the failure is. Return will be, and I'm going to give, this is what I'm expecting. That's my outcome. And I'm just saying data driven. So I'm going to say given, and I'm going to go ahead now and touch on another topic too on this is our mock. So on our mock, we have different, the mock validators, and we can look at that and say, okay, well, we need to check, we need to see how the mock is coming through. And why I picked this is that we're saying if the number is positive or negative, we're going to throw an exception. I'm not going to pass in any negatives right now in this test in the data. So I don't need to have the mock even be checked either. So I can actually, I'm bringing this over just so you guys don't have to see me type every time, is that I'm going to pass in this embedded mock. This comes with Spock. They have mocks and spies. And this mock is just saying, present yourself as a validator for it. And we'll look more into this mock and how to do that. But this is just going to allow us to call it. And since the actual interface doesn't do anything but check and throw a runtime exception if there's a problem. So as long as I don't need a runtime, I can just pass in this mock and I'm good to go. And I have less call to or less connections to other classes. So then I'm going to say when that, I'm going to expect a result. So I'm going to call, and this is all happy path kind of stuff. Happy path results, and here's my number. So you're saying, okay, well, Dave, where's the result? Where's the number? The result's going to come from the class, but where's the number get passed in? I'm going to say, okay, I'll show you that in a minute. I'm just going to do my test though. I'm going to do my Groovy Truth. So I'm going to say result, and I'm just going to say equals the answer. Now I just put in another value in there, and you're like, okay, so I have a number that we don't know about, and I have an answer that I don't know about. Well, this is where the data comes by. I'm going to say where. This is where we say where I have a number, and I just use a pipe, and I have an answer. That is that simple. You can do a table. So you can do all this table for this data. It's not in some file somewhere. It's not anywhere else. It just goes where one comes in. I'm expecting what? A 1, correct? Because if we give in a odd number, we're supposed to receive a 1. Everyone agree to that? So if where the value is in even or odd, return 1 for even and 0 for an odd. So I might have that bad. Isn't that correct? Because that should be return 1 for an even. Or am I getting it wrong? Integer value is an even or an odd number. Return 1 for even and 0 for an odd. Okay, so that's an odd number, 1, isn't it? So I should return a 0, correct?
Yes.
Yep, cool. I try to do this to get the feedback and stuff. It's, pair programming. So I have the 2. So 2 should be a 1, correct?
Yes.
Yep. So now I can just do this quick thing, say optimize imports, clean up my code, and it knows about Groovy, and it just made a lot nicer table. See how it connected to that? So it knows the DSL. It knows how to do this table. I can add in more. I can say, okay, let's do integer. And there's a lot more that I can do, max value. And if it's the max value, what's that value? What's the last value of that? I think it should be if I remember correctly, it should be an odd number too. I think the ending of it, the max value is an odd. We'll find out because our map should do that. So there we go. So there's our answers, there's our numbers, and I'm just going to put 2 more in there so that we can test this out. This is the best thing. It's this simple. So that's an even number, correct? So it should be 1. This is, let's just do 2, 3, 4, 1, 2, 1. That should be 0 because it's a odd number, correct? And we'll test this out. We'll see. So right now, this is going to fail anyway, correct? Because we haven't put any code in our class. If I go look at this class, I'm just hitting the validator, which the validator now is going to be a mock. So it's really not going to do anything. It's just the mock is just going to return. And we're not doing any coding in here except it's checking if it was thrown a runtime, we would be good to go. So we're good to go there, but we're always going to receive 0. So that means 1, 2, 3 out of the 5 times right now, we're going to get passes. We're going to be good to go. But the rest of them we're not, because obviously it's always going to be 0. But that's good because we still need to implement it. So I'm going to go and say, here's my data. And I'm doing this little thing here called unroll. And unroll, if I spell it right, unroll, Alt, Control, Enter. Should have taken it. Input spot. There we go. So unroll says for each line of your table, hit it, and put the data in here if you have a failure. So it'll actually match it up. If you don't unroll it, then it says, oh, you don't care about the output. Well, we won't try to match this method. So it'll allow you to be a little bit more proficient in your code or make it a little bit more faster in your testing. But if you have something you said, hey, I really want to see the number and I see the answer if I have a failure, you really want to do that. So I'm going to go ahead and run this. And what we're going to see here is, as this is running, see the 2 failures? Look at this beauty. This is what I was telling you about. For the given value 2, return will be 1, data driven, just to give you that. This tells you here too, but this really tells me where I was in this table of data to where my test was. So now you really have a great ability to say, where is the data? Where is this failing? What piece of data got passed and what failed? Now it tells you here too, but if everyone knows when you're passing in data and giving anything, it's really nice if you had something to just come and spell it right out here for you. And that's what this does. That's the beauty of the unroll and passing in the names in there. So this is what I really like. So let's go ahead now and try to code this up. Everyone ready to start coding? And this is where, by all means, double check me. And I love pair programming, and please hook up. But I think this is number. And if I do this divide by 2. If it equals 0, I should return 1, correct?
Correct. Is that right? Even?
Yeah, and then, because that's the modulus. So if I don't get anything, it should be even, and then 0. So we'll find out if that's correct or not, because why? I know that this is our requirements. So this is my crutch. I just kind of go off of, oh, now this guy, I can return that one or that one, and this guy can go away because there's no way to reach him. So if you look at this now, I can say, okay, I'm gonna look for the modulus, very easy. I got the requirements, hit that return. So now I'm gonna go ahead and run this. And if my math and everything is right, we should see a passing test. Boom. We met the requirements. We got all the output passed. And if I, we'll let this go for right now. I'll go ahead and see, let me see something here. I'll wait to run in and I'll show you the output on the Excel, on the not Excel, on the HTML page too. Think of your CI/CD pipelines and other things like that when they fail. As a manager or as a, other people, you can say, look, I know it's very easy. It's out of the box. You guys should be showing me this. I should be able to see this. I should see things fail and look at this right away and see readable output to say, look, you guys need to get on this. So that's another test. The other one that I'd like to be able to show you is, and first let's hit, did we hit the setup and the stimulus and response and the cleanup? You guys think we made that? We touched that. So I think we hit that. And we hit the plain booleans. So if I look at that, those two are actually, they've been done. The one thing we have to hit is the interactions and the mocks. So how do we know when something happens, we do that? And how does that work? And so what I want to show you is very easily in this is, and I see our time, but if you guys don't mind, I'm going to give take a little bit more of your time. And with that, I'm going to go ahead and write some of this. I'm going to copy some of the basic stuff. And then on the rest of it, I'm going to go ahead and type it out, the cool stuff. Because we've already done the validator and we've done the odd and even. The one difference here is you guys see that I have an interface because we're doing good programming, writing code to an interface. We call mock on it. You can do concrete classes in Groovy too, in Spock. So this could have been the validator impl. See, I'm getting the wrong. Where's my what did I call it? Negative validator, yeah, or negative checker. So I could have done this, and it would have still worked because it implemented this interface, and I could put this here. So if you need to kind of get at some implementation class methods that the interface doesn't have, and you want to test it, you can do that. So you're not tied to the interface only, but good programming practices, you should probably see your mocks have the validators only. And inversion of control, what are you doing? You're injecting the interface. So your contract is the interface. So we're expecting that the odd even camp, what is it going to do when it has this? We want to see, okay, what do you do? And is it really interacting and testing it? And does it throw an exception? How does it work on that? And make sure you have an exception throw. So we're going to say when that's called, I want to see if this validator that's been called, this mock, I'm going to say, hey, you've been called, do something and see how the concrete implementation works. So when you call here, do something. I want to see how you how it gets handled. So you can inspect stuff. So I'm going to say this. You see this one in the star. That means I'm expecting the this mock called the negative checker to be invoked one time. Its method called validate. Here's the other thing. I can say I'm expecting the number 0 to be passed into it, or I can say I'm not sure what number and just pass that in. I don't even know the type, or I can put types like integer, because I know it's going to be an integer class or something like that, but I'm not sure what one it is. But I like the very explicit, like I know that validate should be called one time with the number 0. You can pass things like from your data that I know that this number, the value answer is going to be in there. So I could have used answer too in other ones. So I can say, I am expecting that. When that happens, what do I want to do? So this is, the closure of throw a new negative number. I can type number exception. And I'm just going to put in for this, it's a negative number. So I'm expecting that this is when the mock gets called, I'm going to throw this negative number exception. I didn't write the validator class here. I'm not controlling that exception. Yes, we passed it in at the top so I could show you, hey, there's the mock, and you can actually pass it into by default when we first tested it with a real one. But here, I'm actually going to say, look, I really want to pass, or here I did it there. I did it on this one where I passed in the real negative checker, the real class. But in real life, I'm going to say, look, I don't want to be beholden to whatever that validator is, because I'm doing inversion control. I'm saying, look, I just need whatever follows that interface. My code should be able to handle it. So what I'm expecting to happen is what's thrown is a negative number exception. Because I know that my code should not suck up that negative number exception. It should not, it should let it through, because that's part of the contract. So if someone changes or does something or writes code in this odd even camp that does a try catch here and stops it, well, now we got a problem. So how do you solve that? And you test for that. I'm saying, hey, when the validate gets called with that 0, you throw that exception. There's many other scenarios for this, but I'm going to just run it here, and you'll see that it's going to throw it, and I'm going to expect it to be thrown, and boom, it'll come out. And only one time too. This is a key. So think of looping and other stuff like that, where, hey, in my loop, when I get a record set or records of 6, I should only have, it should be called 4 times or 5 times with this data. You can be very specific here, or you can be non-specific. You can go like this. And now that's just saying, I don't know, whatever. But I know it's supposed to be called one time at least, at least something. Or it can maybe be called, or you could just do this. Okay, if it's called. But this really says one time and only one time. So we got a pass, we got a green result. What I wanted to do is to show you too is, hey, one wasn't called. Do we have some crazy code or something like that that actually is messing with us in there because we're working with this other interface passing in our code? So I can put this in there, and it's going to error back out and says, look, I'm a mock. I'm actually a spy, not just a mock. I'm spying. You said that I'm supposed to be a negative number exception. I was supposed to be invocations of 1. I had 0 invocations, and you said I was supposed to be 1. You see how powerful that is in that SPI? And there's no extra stuff you have to do or bring in this language, this thing or that. It's just fluid in the language itself. So I'm going to put back the 0 there and run this again. And you'll see that it'll come through. So it all passed. I expected it to be called once, and it was called once right here with the specific number. So if I did some kind of weird stuff here too, someone came along and said, oh, if it's 200, if number, who knows? Some developer says if the number equals 200, then change the number, which you should shoot this developer, but I'm joking. Get very mad at the developer. Change it to 3 or whatever. So 3 is going to be passed into this number if it's 200. Yes, this is illogical, but I'm telling you, I've seen code like this kind of craziness before. So we want to be defending against that. So if I pass in a 200 here, I'm expecting 200 to happen here. Don't you think? That validate should be calling it. We're like, hey, so if someone went and changed that code and we ran our unit test, we're going to get an error now. And why? Because we got 0 invocations because someone came up here and started changing code and ruined the contract of what we needed. And we were like, look, you're not supposed to be doing that. You're supposed to be, it's supposed to be the number that you pass in should be calling validate, and that's it. Now, you can say, well, no, it's supposed to be that code now. Well, if it is, then that developer has to go in and know exactly where the test is, know what the behavior was, and says, oh, okay, well, we're not doing that anymore. It's always going to be 3 if 200 is passed in. So now, if I go back to this, just put that back up and say, no, that's actually the requirement now. At this very unique number, 200, I'm just pulling up stuff just to say how powerful this is, that you could say, well, no, if you pass in 200, really this validate method should always be receiving a 3. Okay, but if you read this and you see the test, the code is telling you that, and there's not a lot of ceremony. It's more explanation, the DSL. Does that make sense to everyone? So that's the power of this. To me, it's a lot easier and quicker to ensure that the DSL is there and working for you and not being hindering you, but explaining what your code is supposed to be doing and helping the person, the developer, if they're updating and maintaining that code. So if I run all of these again, then I'll try to refresh my page. And see what we got. Yep. Okay, cool. So I'm going to bring over my little report page because everyone wants to know, hey, we want to celebrate. We want to celebrate failures too in the CI/CD because at least we got them, and we want to know. We want to see high levels of tests and the success rates, and there we go. Your instrumentation, like what was your test coverage, will come up on this too. So I can see here that 7 classes and all the outputs were done for the given value of 18. Boom. The given value of that. You look at that, that's all the data. So you get a really good, what was done and what wasn't. Here's our number, that long number. Remember I told you that we wanted the max value and stuff. So everything is printed out because I did the unroll. And you can really see the data and what was driven, what was your coverage in the sense of what data was used for all of these. And then here's our negative check still too, that's just the basic one and it passed. So now if I look, I'm pretty sure now that we covered the Spocks and the interactions of those and how you could test it by using this way of doing the validate and what should be expected out of it and how you can do that. So if I come here to the README, I should see that the spot, I saved that, the Spock fixtures now, or the Spock interactions are now checked off. So our last thing is our fixture methods. So our setups and going. So what I like to do here, just because I don't want to bring in a lot of different code and spend time, I'm just going to print out. In Groovy, I just do a print line. And I'm just going to do setup spec. And then I'm going to do print line. Setup. And then the other thing I'm going to do so that we don't have so much chatter from the other ones, the outputs and stuff, because I just want to show you this. I'm going to do this and put this on the other class instead, the other test class, so that you can like really see the what is happening here. This is cleanup, and this guy would be cleanup spec. And I'm just tired of typing. So this is cleanup. Just so you guys can see this. You know what? I'm going to leave this here because I'm going to show, you should see all the different times it prints out, and we should see the output on that. Let's go ahead and run. Let's see the other one. Let's just run this and then that will be our last part. So there's our setup spec and setup, cleanup, setup, all the different tests. And you see there's the cleanups. What is the cleanup setup? Didn't I print that out? Oh, I forgot. I just did, oh, that was my bad. I connected them. Sorry, let me run it again. I was like, why is it cleanup setup? I didn't do the print a new line. Because you have setup and then you cleanup, setup and then cleanup. So if you guys see, there's the setup and cleanup all the time, but only one setup spec and only one cleanup spec for the whole entire, all the methods inside of it, all the tests inside of it. But then for each one that's executed, you get a setup and a cleanup. So for every line, so that's even also for all those data lines too. If you needed to pass some data, like to insert into a database, and you're using that data table to insert it in, you could still do that and say, okay, well, I need this mock to see that data get passed in and it come through and stuff. You can do that and then clean it back up. So that's the setup and cleanup spec and how you would handle that and, you know, use that just like JUnit. You know, no big things there. So that hits on the fixture methods, which are like the initials and the closing. And that would, if there's any questions, I didn't see any hands go up when we were going. If there's any questions of the Spock and how that goes, I'm open and ready to take any extra questions. I'm trying to get to my one file, my one class. I'm just trying to go to where my presentation was because it's now, I can't find it. I don't know if I got rid of it. Just give me a second. I will try to resume. I don't see it. Darn. Well, on my web page or on this thing, I have a link to the presentation too. Oh, here it is. There we go. So that's it for the presentation. Sorry, it was a little bit. So there it is, David Dry Perry for my Twitter if you want to reach me, or to davidperry.com. I don't post a lot on davidperry.com or anything, but that's just kind of like my homepage since I've had forever. I want to thank you for your time. If you guys don't have any questions, that's it. Cool. Thank you. I'll give it back
Good job.
to maybe my friend or known friend.
Former friend, I guess we should
Luke.
say.
Former? What? After this talk, it's a former, huh?
Yeah, no, it's great. Yeah, thank you, David. That was very interesting. I think a great introduction to show the power of Spock. I think we will all live long and prosper.
And test-driven development. Everyone talks about it, but not very many people do it.
Yeah.
Yes.
I think
And
it's
that
great
was-
to.
Yeah. And business-driven development, they want to hit on that. So Spock says, because you can put that data in there and have more of the language flow and stuff, you can really expose the business rules by doing the spies and the mocks all together in one thing. But
It's a cool little framework.
And the one thing I didn't catch on this too is I've actually had a really good positive feedback of going over it with business owners of, hey, one was like doing emails and other things like that. And like, hey, what would you want? What are you expecting? And how are you supposed to look, or how you expect this with this data, or how this works? And say, look, I'm doing this. And then saying, look, I want you to have more ownership of what you're seeing and expecting, and doing that. And they could actually see it at a higher level. And, you know, I've had people actually use Spock at a higher level, do integration or like more business level calling out to stuff. So to take it to the next level, I use it for units, but you can think of this, that they could actually go and call websites and test things and have a more, explaining, language to them. So
Really cool to see it in action, and yeah, very readable. I would say a lot of that is, yeah, it seems like it would be good to, yeah, people can, even non-technical people could read through it and see, does this make sense? Is this how we want it to work? Is this the right business? Are these the right test cases to be, testing, and how well does it follow what we expect? So I think it's a really good primer on all this, and I'm sure somebody will be watching this many years later and saying, thank you, David Perry, for presenting this.
Well, thank you. And will under GDG branch, what I went over, it's very close to the other one, but I will have this GDG branch that I will commit from everything that we did, and that you can reference it. So
cool. Thank you, David. I'm going to stop the recording, and then we can have our little social wrap up.